Hi girls. Tonight's video we're going to continue in the section we started in class today in Unit 4, Section 4.2.1, where we were talking about working with two different, and they call them categorical and quantitative variables. So we're working with two variables now instead of one like we did in Lesson 1. So in the first section today we're going to be summarizing data using a two-way frequency table. So we started with our warm-up today. We completed that. And then we went into our next example where we looked at joint frequency. And again, for joint frequency, that means that we are looking in a column and a row. And we're looking for the data point that fits both of the frequencies. So it's considered a joint frequency. Also in class, we talked about example 2, where this time we looked for something called marginal frequency by each type of pet. So that meant we needed to total the number of pets. So we were totaling each column. If it had asked us for the marginal frequency by each grade, then we would have totaled across the rows and found the total for each grade. And then the last example that we looked at had to do with finding the conditional relative frequencies, which means we add up every single data point in the entire two-way table. We found that to be equal to 83. And then we find the percent that relates to each of the boxes. So if there are 2 students in here, then 2 out of 83. When we do the division, is 0.024 divided by 83 gives us, 2 divided by 83 gives us 0.024, which is 2.4%. We did that for each one of the boxes and filled in the percent there. In some cases, they want you to redo the table with the new data. We didn't do that in class, though. So to continue on, in class, we looked at this particular example, and you were asked to group these students by age groupings. So when we looked at the next page, it said create a two-way frequency table showing the joint frequencies of visitors with the following age ranges: 5 to 15, 16 to 25, 26 to 35, 36 to 45, 46 to 55. Include in the table the marginal frequencies for the types of attractions and for the ages of the visitors. So we're going to total the types of attractions and we're going to total the ages. Are there any trends in the types of attractions preferred by each age group? Use conditional relative frequencies to describe your response. So you started on this table in class and it would look like this. I place the age ranges in down the first column so that my age ranges are going across in the rows, and I put the attractions as the headings of the columns. Some of you reversed these. Some of you had the attractions here and the ages across the top. That doesn't matter at all. You will still get the same exact data. So the next step was to look at the marginal frequencies for each type of attraction. So what we need to do for that is for each type of attraction we're going to create a total. So I'm going to actually add a column at the bottom here, or another row at the bottom for the totals. So when I total all of my roller coasters, I get 17. When I total all of my shows, it's 22. And when I total everything for water park, it's 11. It also asked us to find the marginal frequencies for the ages, which means we need to total across the rows. So I'm going to create a new column that will show me those totals by each age group. So when I add across, I get 9, 11, 14, 6, and 10. So now when I look at my table, I want to see how the values are distributed in each row, and that will help me understand how each age group, or if I look at each age group, which attractions they preferred. So if we use the conditional relative frequency, which would be the joint frequency divided by the total number within each age group, that might help me. So that means I'm going to look across my row, and I know that I have 9 visitors who fell between 5 and 15. So if I want to understand my conditional relative frequency in each row, I would take 2 and divide it by 9. So 2 divided by 9 would give me 0.22. 4 divided by 9 would give me 0.44. And 3 divided by 9 would give me 0.33. So I'm not doing it by the total, I'm looking across by age group. So I'm going to do the same thing, and I'm going to fill in the rest of this table. In this case, my total in the age group is 11, so it would be 5 divided by 11, 0.45, 1 divided by 11, 0.09, and 5 divided by 11 again, 0.45. So I'm going to go through and fill in the rest of this table. 0.36, 0.17, 0.4, 0.57, 0.67, 0.5, 0.07, 0.17, and 0.1. So now when I look at my data, I can analyze it by age group. If we look at the 5 to 15-year-olds, those numbers are pretty evenly dispersed. 22%, 44%, 33%. In that age range, they seem to like all 3 of the attractions. But when I look at the age range of 36 to 45, only 17% like roller coasters and only 17% like the water park. They prefer to go to the shows. And we also see a difference in the 26 to 35-year-olds. 36% and 57% like roller coasters and shows, but they don't seem to be very interested in the water park. So this is why we did our conditional relative frequencies across our rows so that we could do our analysis by age group. So tomorrow in class we'll take a look at another practice for a two-way frequency table. We won't be doing any more of these today. The next thing we're going to talk about today is section 4.2.2, solving problems given functions fitted to data. So what that means means that we're going to start with a table. So let's look at our first example. It says Andrew wants to estimate, and in your workbook, that's page 59, so get out page 59 from your workbook. It says Andrew wants to estimate his gas mileage, or miles traveled per gallon of gas used. He records the number of gallons of gas he purchased and the total miles he traveled with that gas. So here's the gallons, here's the miles. It says create a scatter plot showing the relationship between gallons of gas and miles driven. Which function is a better estimate for the function that relates gallons to miles? Y equals 10x or y equals 22x? How is the equation of the function related to his gas mileage? So at the bottom of this page, we are already given a graph. And what we do in this instance when we have two variables is we just go ahead and graph our function as if this was an x and a y table. So we're going to make our gallons our x and our miles are going to be our y. So let's look down here at our table, and I'm just going to plot those points. So I'm going to plot the point 15, 313. This is going up by 20, so 313 is going to be right about here. So why don't you take a minute and plot all of these points. All right, so when we're done now, your graph should look something like this when you've plotted all of those points. So the next question we were asked is, which function is a better fit for this data? So we would go ahead and graph the first line, which is y equals 10x. So when we graph the line y equals 10x, it looks like this. Now we have to do an analysis. Is this line a good fit for that data? Well, I'm going to say absolutely not. My data is up here and my line is way down here. So the next question was, what if we graphed the line y equals 22x? So on that same plot, I want you to plot the line y equals 22x. And when we plot this, and the only thing you need to do is plot 2 points. Let's look at how we did this. I know my function is y equals 22x. I could plug in 0 for x. I get 0 for y, so I plot the 0, 0 point. I could plug in 10 for x, and I get 220 for y, so I would plot 10 and 220, and then I would draw a line through my points. And you can see that this line is a much better fit because it seems to go nicely through the data points. And when we're looking at the slope of a line, if our equation is y equals 22x, that means our slope is 22. And in this case, our slope is the change in the y values, which in this case, our y values is the change in miles over the change in gallons. So that's miles per gallon. And since our slope is 22, we are looking at the gas mileage for Andrew's car is approximately 22 miles per gallon. All right, let's look at example 2. The principal at Park High School records the total number of students each year. The table below shows the number of students for each of the last 8 years. Create a scatter plot showing the relationship between the year and the total number of students. Show that the function y equals 600 times 1.05 raised to the x is a good match, or is a good estimate for the relationship between the year and the population. Approximately how many students will attend the high school in year 9? So you need to pull out a graph this time and create that x and y axis. So in this case, we will put the year along here from 0 to 15. We will put the number of students. We went up by 100 here. And go ahead and plot all of your points. So you can pause the video and go ahead and plot the points, and it will end up looking like this. The next thing that we were supposed to do is check and see if this equation is a good fit. So how do we find that equation? So I would create an x and y table based on our equation. So when I plug in 0 for x, I get 600 for y. I would plug in 1 for x, 630 for y, 3, 5, and 7. So now I have several data points that I can use. I put those data points on my graph. They're listed as x's so as not to confuse them with my points. And then I draw my curve through those. So you can tell when we look at this curve that that function that was provided is a very good fit for these data points. So for the rest of your homework tonight, I want you to complete example 3. It says the weights of oranges vary. Maria wants to come up with a way to estimate the number of oranges given a weight. She weighs the oranges and records the weights in the table below. Create a scatter plot showing the relationship between the number of oranges and the weight in pounds. So go ahead and make that graph tonight. After you've plotted all of these points, is the function y equals 0.6x minus 0.5 a good fit for the data? So next I want you to graph that line, and then you will see whether or not it's a good fit for the data. Lastly, answer the question. Maria has a bag of oranges that weighs 2 pounds. Approximately how many oranges are in the bag? So in this case, when we're graphing, just so you know, our number of oranges will be x on the axis and the weight in pounds will be y. That's it. So I'll check on example 3 tomorrow as far as your homework goes, and we will continue working on both of these sections tomorrow in class. Don't forget, we have a formative assessment on lesson 1 tomorrow. It will be all multiple choice at the beginning of class. See you tomorrow.